How does yaw rate affect vehicle stability and handling? Imagine you're driving through a sharp turn and feeling how your car responds. The way your vehicle reacts depends on a key factor called yaw rate. Yaw rate is how fast your car rotates around its vertical axis during a turn. It's measured in degrees or radians per second. This parameter is vital in understanding how a vehicle handles and stays stable when you steer. When you turn the steering wheel, your car's yaw rate changes, and that change influences how smoothly or sharply the vehicle responds. If the yaw rate is too high for the steering input, the car might oversteer, causing the back end to swing out. If it's too low, the car might understeer, meaning it doesn't turn as much as you want. Both situations can affect safety and control. Yaw rate is directly linked to the yaw moment, which is the torque around the vertical axis that causes the rotation. This torque depends on factors like how weight is distributed, the suspension setup, and tire forces. Proper management of this torque helps keep the vehicle stable. If the yaw moment is imbalanced, the car can become unstable, leading to skidding or spinning out. Yaw rate also relates closely to lateral acceleration, which is the side force you feel during a turn. When you go around a corner at a certain speed, the yaw rate multiplied by your speed equals the lateral acceleration. This relationship helps engineers understand how well the vehicle maintains its path and how forces act on it during cornering. Modern cars use sensors to measure yaw rate constantly. If the system detects that the yaw rate doesn't match what's expected for the steering input and speed, electronic stability control systems step in. These systems can apply brakes or adjust engine torque to help keep the vehicle on its intended path. Engineers use mathematical models like the single tracks or bicycle model to simulate yaw rate behavior. These models help predict how changes in steering, speed, or road conditions will affect handling and stability. When it comes to practical driving, if the yaw rate is too low during a turn, the vehicle understeers, turning less than expected. If it's too high, oversteer occurs, and the rear might swing out. Achieving a neutral steer means the yaw rate matches the steering input and speed, resulting in predictable handling. In essence, yaw rate is a key piece of the puzzle that determines how a vehicle responds during maneuvers. Understanding and controlling it allows engineers to design cars that handle safely and predictably, whether in everyday driving or high-speed racing.